everyone, I am Dr. V.S. Nishok from EC Department, SNS College of Technology. Here we have gathered to discuss the topic sine wave generators from the subject linear integrated circuits. So this is the outline of this video. It starts with why do we need sine waves, and it continues with Barkhausen criteria and types of sine wave generators, and ends up with the practical applications. So why do we need sine waves? In real world applications like voices, music, everywhere we will be using the sine wave as the input. Since it is smooth and continuous waveform, it produces less noise and harmonics. That is why it is low distortion. So it has no sharp edges, and it will be used for testing and filtering amplifiers, and it will be foundation for audio and communication systems for transmitting the signals. The problem behind using the waveforms. Continuous sine wave is needed here for such applications, and it should be with fixed frequency range. So without any input, we need to provide the output from this sine wave generator. So, and the output should be stable. So these are the needs here. And coming to what is sine wave generator? So it is sine wave generator is an electronic oscillator. So that is without any input, there should be a output with feedback connected to the input of the operational amplifier. That is we call as a sine wave generator. So the generator provides the sine waveform without any drop in the output. So here coming to the Barkhausen criteria. So Barkhausen criteria represents 2 points to provide the sustained output of the oscillator. So the first point mentions about the loop gain should always be equal to 1, and the next point represents the phase shift in the output should be either 0 degree or 360 degree phase shift. So coming to the types of sine wave generator. So based on the uses, it is classified into RC oscillator and LC oscillator and crystal oscillator. So RC represents the combination of resistor and capacitor circuit, and LC represents the inductor and capacitor circuit, and crystal represents the instead of resistor, inductor and capacitor, we will be using the quartz crystal in the circuit for providing the better result. So coming to the RC oscillator, it is classified into Wein bridge and phase shift, and LC is classified into Hartley and Colpitts oscillator, and finally the crystal oscillator is classified into the digital clocks and microcontroller applications. So the major difference between the RC, phase shift and Wein bridge oscillator, both comes under the category of RC oscillator. So that is resistor and capacitor based circuit. So here the RC phase shift provides less stability than the Wein bridge oscillator. So with the help of the lead lag circuit, this Wein bridge oscillator provides the stable output and pure sine waveform when compared to the RC phase shift oscillator with more complex circuit components. So this is the time for activity. And coming to the practical application, since the 3 classifications uses different sort of circuit in order to adjust the control the frequency. So this RC phase shift oscillator with less stability provides low frequency audio signal applications, and it will be used for simply generating the sine waveform. And then coming to the Wein bridge oscillator, so with high stability, it will be having low distortion, and it will be used for function generators and audio oscillators and precise testing it will be used. And LC oscillators with high frequency range, it will be used for radio communication and RF signals and radio transmitter and carrier communication circuits. And finally the crystal circuit with quartz crystal will be used for, even though it is very expensive, it will be ultra stable frequency reference. It is having very high frequency range stability, and it will be used in clocks, digital clocks, microcontrollers, precise measurement devices, etc. So that's all about the practical applications, and we are moving to the summarization part. We have started seeing about the what is sine wave generator and what is the criterion, that is Barkhausen criterion behind the sine wave generator, and then coming to the different types of sine wave generators like RC, LC sine wave generator, and crystal oscillators, etc. And we have ended up with the practical applications. So this is the time for assessment. It starts with which of the following is a condition for sustained oscillation in the sine wave generator. So the answer 3 is the correct answer. Loop gain modulus of A beta should be equal to 1, and phase shift should be either 0 or 360 degree. And the second question is the frequency of an RC phase shift oscillator is given by option B is the right answer. So, and this is the reference materials we used for this video, and I hope it will be useful for everyone. Thank you all for joining this video. Thank you.